Hey, Sarig, what are you doing?
Yo. Well, I want to be looking at the role of small scale manure management in representing different systems that handle manure in a more conventional sense and in a more alternative sense. So here we have a diagram depicting a typical representation of leaching into the groundwater. And we see that losses to soil are seen as one of the highest contributors to leaching. So, in this way, we can view the role of soil biology as a potential adapting strategy to handling manure. And this can be seen in this comparison of two small scale systems that integrate manure very differently. And using soil profiles, we can observe these differences through soil interactions.
Hey, here we have a compost pile, and we can start with just discussing why a compost pile is a sustainable way of managing manure because of the way that it utilizes the biology and microbiology to break down the nitrogen uh, along with the carbon a, in a more mineralized and plant available form. In the process, we can also obtain a growing medium which can retain much more water than just if we were to throw manure on the ground. Also, it's much more pathogen free, so it's much more stable rather than just throwing manure on the ground. And so one of the ways that we can evaluate the differences in different parts of soils that have been exposed to different management practices is to physically look at the soil through a soil profile. And so I've already done the first soil profile. And what we're looking for is different like levels of porosity, whether there's any anaerobic pockets. So in this way we can see the color change. It goes from kind of a loamier, darkier, and here we can also see it's much more grainy and smooth, to a bit more of a sandy layer, which indicates to a compaction layer. And we have a bit more evidence of compaction and an iron oxide layer here with the orange pockets. And after about a meter, we've already reached the water and a pure clay layer. So this is a cool way of just kind of looking at the ground. And so what we want to do here is now to compare this soil profile with two other soil profiles. This is the second soil profile site. And before we start digging this pit, I just want to show you a bit more about this business as usual manure management practice. One thing I didn't mention, and I should have mentioned it probably, is that this is my neighbor's plot. So this is what we referred to in the beginning as the difference here. So I'm going to be showing you my neighbor's business as usual manure management approach. Maybe something else I should also say is that this is a kind of example of the normal conventional kind of approach that's typical of small scale and large scale farmers in the Netherlands. So regulation in the Netherlands states that the manure needs to be collected on a concrete plate and be disattached from the ground because there's that leaching problem. You can see the sheep there in the background. They hang around outside most of the days. Sheep poop. And this is how it's kind of collected and stored. A few problems here, as we can see, is that concentration of kind of leachate, which is then just flowed down into the pipe.
Between buildings and cars.
What I've been doing since I've been kind of in this area is trying to utilize some of this manure and composting it so that it changes transform physically, chemically, and also biologically, and then it's not actually it actually retains the nitrogen in the microbiology rather than leaching it in the form of nitrate to the groundwater. And so yeah, this is a really small scale example of a big pile of concentrated sheep manure, but you can imagine that in larger operations the risk increases dramatically because of this concentration of manure. And the basic issues here from a composting perspective is that there's not enough carbon to break down the nitrogen. So that's why organizing it in a compost pile it increases the chance that you can actually break down enough of that nitrogen ecologically.
Ooh, wee. Did you smell that? No. Yo, I'm glad you don't smell that because this pit is stinking. Yeah, it's definitely different than the previous pit. If you come a bit closer, you can maybe see the color change. First of all, look at my hands, very, very sticky, indication of really high clay content. And you can see, as opposed to the previous one, this is already immediately clay from the get-go. We see here an immediate kind of compaction layer and just, yeah, pure. We reached water, I mean, in half the length that we did in the previous one. So it's very interesting to see the differences in just maybe, what, 15 meters away. This kind of land has been used more for the occasional sheep that wander here and inhabit and just graze. So maybe over time that could have resulted in a sort of compaction. But I think it's mostly to do with the fact that the grasses are consistently cut and mowed. So, I mean, historically this land is a peat-dominated area. So the groundwater is really, really, really high. So it doesn't allow for really deep grassland roots to develop. But it's quite interesting just to notice the difference of impact from a more biologically enhanced kind of compost pile that's only been operating for about a year, that's already increased the soil organic matter content visibly, as opposed to something like this that's been here, I think, for about 30-40 years, just the same, constantly mowed and occasional sheep grazing. So yeah, that a bit more about that smell and the relationship between nitrogen leaching and compaction. I mean, kind of throwing these words loosely and kind of synonymously, but there's a massive distinction. The compaction can enhance the likelihood of nitrogen leaching. So a compaction layer deep in the ground, either as a result of consistently high groundwater levels, which is kind of the case in Netherlands because of obviously the lowland region, and also through kind of above ground factors such as machinery or maybe animal trampling, livestock grazing. But here it's definitely more of the geomorphological peatland dynamics that have dominated this landscape historically. So yeah, let's see the last pit and we can check out the differences.
But she couldn't have gone far.
Ooh, this one smells even worse. Yeah, just come a bit closer. When I speak about the smell, I don't mean the piles of poo, I mean this pit. The fumes coming out of this pit are really, really bad. And that tells us that this is even worse in terms of the nitrogen emissions and leaching than the previous pit. And if you come a little bit closer, we can see a key difference with this pit with the others, and this is the kind of putrefying organic matter, which means that it's not actually breaking down, it's just kind of being preserved in the anaerobic condition underneath the ground. And this is where the relationship with the compaction layers and nitrogen leaching can be really, really seen, is that because of the compaction of these clay grounds, these clay soils, the organic matter cannot be broken down efficiently, and so it just kind of putrefies and just lays there, and that's a classic kind of form of peat lands. And otherwise you can also see these kind of changes of layers. So here we have kind of the top layer, which is not as clay as the previous pit, but still quite clay, and we can see immediately this kind of putrefying organic matter layer. And here we really see a black soil, and this is really indicative of nitrogen leaching in terms of just these black kind of organic matter rich soils, where the nitrogen hasn't really been broken down.
Just follows her star, and I've lost my love in a pile of chopped onions.